We're getting into the final shows for the Return of the Rat tour. Gosh, this rat is almost fully returned. July 9th, we'll be in Philadelphia, Rochester, New York on July 10th. Then we're in Detroit after that. Moving on, we're in Los Angeles, Anaheim, at the Honda Center in Oceanside, California. You can get all your tickets at theovon.com/TOUR. And just thank you so much for your support. Today's guest is a neuroscientist. He's an author and a professor at Johns Hopkins University in Baltimore. He's written books about addiction, love, death, and what it means to be human. I'm really grateful for his time. Today's guest is David Linden. David, are you physically comfortable in here?
Yeah, sure.
Is it too hot or cold for you?
No, it's just fine.
It is?
Yeah.
Okay.
And I'm happy to see that my actual name is there. It's not just brain researcher or something generic.
No. We only do that. Sometimes we'll do that if it's every now and then we try to get like regular folks out of society in. And sometimes we try to keep that kind of a little bit generic.
Well, you know, my wife was teasing me, of course. She said, oh, yeah, like, so you're going on there and there's been like President Trump and Bernie Sanders and David Spade and then some scientists nobody's ever heard of, like, you know, like who doesn't fit in this picture?
Hey. Well,
and so I had imagined, you know, brain guy.
Well, look,
all right.
We're happy to have you, man.
Yeah.
We're happy to have you. Neuroscientist David Linden, right?
That's me.
Okay. And so as a neuroscientist, how do you practice that like in everyday life these days? I know you are a professor.
That's right. So I'm a professor at Johns Hopkins Medical School. And so until very recently, what I did every day was to run a lab where I did research with mice working on brain diseases. But the other things I do involve teaching medical students, teaching graduate students, and then very recently also teaching undergraduates. Yeah.
Well, thank you for your service. I think being a teacher and an instructor is a service in a lot of ways, and I think it kind of maybe gets overlooked sometimes. I'm not sure if that's true, but yeah, thank you for your service. When you're testing these mice for neurological diseases?
Well, yeah. So, for example, one of the things that we're interested in is recovery of function after brain injury.
Okay.
So you probably have heard that if you get injured in your spinal cord or your brain, your ability to recover is minimal. Like if you cut a nerve, you get injured, you cut a nerve in your arm, it'll grow back and you'll be fine. But people get injured in their spinal cord, typically paralyzed for life. You get injured in your brain, you can recover a bit. But particularly when you're an adult or old like me, your ability to recover is very limited. And some of that is because the long, thin information-sending part of the neuron, which is called the axon, can't grow after it's damaged.
At all?
In the brain and the spinal cord. It can, like in your arm or your leg. And that is some of the reason why it's so hard to recover from brain or spinal cord injuries. Mm-hmm. And so what we're trying to do is develop therapies to allow that to happen so people can recover better from a stroke or a traumatic brain injury like a soldier might get or someone might get in an accident like a car crash.
And so with an actual mouse, what are kind of the processes of doing that? How do they cause the injuries?
Well, you know, we're from Baltimore.
Yeah.
So we do a very Baltimore thing, which is we stab them in the head.
Is that true or not?
Well, that's one way we do it. So we also do another Baltimore thing, which was we get them really high on amphetamines. So yeah, there's a kind of amphetamine which fortunately isn't actually a drug of abuse. We just use it in the lab called parachloroamphetamine, and that fries out a particular kind of neuron that uses the neurotransmitter called serotonin. And so it turns out these neurons that use serotonin counter to the belief that everyone's had in science for years and years, actually can regrow after they're injured. And there's another kind of neuron that uses a neurotransmitter called norepinephrine. They can regrow too, but they're just a tiny fraction of the kinds of neurons in the brain. And so the goal is to try to figure out, well, what's special about them? Why can they regrow when the other neurons can't? And then use that as a clue to try to develop therapies so that the other neurons could regrow too, and people would recover from their brain injuries or their strokes.
Wow, it's exciting.
It is exciting. It's been lots of fun. Hopefully it'll lead to some cures.
I like your attitude, man. That has me kind of thinking, so I know that I take antidepressants, right? I think that's popular. You just mentioned SSRIs. You just mentioned those?
I mentioned serotonin, which is the first S is an SSRI, yeah.
Okay. Does taking SSRIs damage our brain?
Well, taking SSRIs doesn't damage the serotonin neurons, but taking SSRIs has all kinds of bad side effects. I'm sure you know about some of them. One of the ones that is most common is reducing your libido, your sexual desire.
Yeah.
And so the other big problem with SSRIs is they only work so-so, right? Actually, if you look at people who try SSRIs for depression, about a third of the people will say, oh yeah, that works pretty good. I feel, maybe not totally better, but enough that I can notice it. About a third of the people will say, oh, very minimal, just a little bit better. And about a third of people say it didn't do a thing for me at all. So, it's better than nothing, but SSRIs are not that great. And they're not as good as exercise. They're not as good as cognitive behavioral therapy. And whereas exercise has side effects that are good for you, SSRIs has side effects that are bad for you.
It's funny you say some of this because for myself, I notice I've been on my thing for 20 years or something. If I am really feeling sometimes overwhelmed, I almost need to get off of them or I will lower my own dose.
Really?
Because sometimes I can't get feelings out of me, it feels like, because they're kind of stopping it somehow. I don't know the science behind it, and I don't know if that's true, but that's how it feels to me. Does that make any sense?
If it feels to you, then it's true, right? Everyone responds a little differently to these things. Some people it works, some people makes them feel this way or that way. But, your experience is the truth.
Yeah.
We're talking about a drug that's supposed to change how you feel. So how you feel is real. It's not like anyone could say to you, well, that's not true. That's bullshit. No, that's true. That's what's happening for you. And I'm sure for certain other people as well.
Does that heighten serotonin? Does it make it so you can't have certain feelings?
Well, it does. It does damp people down a bit. For some people, it kind of sedates them. Like some people, I know people on SSRIs who will take a little Ritalin too because they have a hard time concentrating enough to work while they're on their SSRIs. Some people will take drugs like yohimbine to try to get back the sexual desire if that's been dampened out by the SSRIs. But, you got SSRIs, they're a stopgap solution. They're not nearly as good as they should be. It's embarrassing for the field of neuroscience that after all these years working on depression, we don't have something better, that our understanding of depression is so bad that we can't offer you a better therapy than SSRIs.
Well, it's kind of fascinating to hear you say that. Do you think that is because of there's not enough science, there's not enough information? Is that because pharmaceutical companies are so happy with the sales that they adjust where they put their funds? Or is it just a research issue? Or what do you think there?
Yeah, so I think it is a research issue. And I think part of it is that in neuropsychiatric disease, sometimes when we make a bucket and we throw lots of things into that bucket, we say, oh, depression, that's the bucket. Well, depression can manifest in all kinds of different ways. There's a depression where you just feel low and unmotivated and nothing makes you happy. And there's another kind of like agitated depression where you're like really on edge and anxious. And we call those both depression. But are they really the same? Well, probably not. They're probably not. We know they're not an experience, and they're probably not in your brain. as well. But let me give you an example of a way in which there's some hope for moving this forward. So the serotonin neurons in the brain are in a part of the brain that's called the raphe.
The raphe.
The raphe, yeah, R-A-P-H-E.
It sounds nice.
I know. It sounds cool, like you'd name your kid that, right?
It sounds like a nice place to take a vacation, like a honeymoon.
That's right. We're going to raphe, honey.
Yeah.
So the raphe nuclei have serotonin neurons in them, and they go all over the brain. And when we go in with an electrode to record the electrical activity, we would say, oh, maybe there's 2 or 3 different kinds of neurons that use serotonin in the raphe. Well, it turns out now we've got techniques where we can take these neurons one by one and analyze the genes that are turned on in each of those, in each individual cell. So there's like 20,000 genes in the genome. A typical cell might express 12,000 genes, have those turned on. And that varies a bit from neuron to neuron. So you can say, how many flavors of serotonin neurons are there in the raphe? Turns out there's 14 flavors.
Wow.
In the raphe. Well, probably only some of those have to do with depression. And some of them have to do with other things, maybe some of the bad side effects that you don't want from your SSRIs. So what this means is that this kind of knowledge, knowing all these different subtypes, means that maybe that can be the basis of knowledge to develop therapies that are more specific, that will work on the mood-altering serotonin neurons and leave the other ones alone and be able to have us make a better drug or a better therapy.
Interesting.
Yeah.
I've loved a lot of your work. I saw you had a great conversation with Andrew Huberman, and he was just on recently. He's a very fascinating guy, a lot of information, and he's great at sharing information out into the world. I believe he's a great conduit for information. I wanted to talk to you about love, I guess, right? I figure it might be a neat place to start, kind of. Did human beings always love, or was that something that we learned over time?
Well, that's a hard thing to know. We can't look at the fossils and know whether people loved. What we do know about humans is that our mating system is really, really, really unusual. All right? So humans have a system where in one woman's cycle, she usually is only mating with one guy. Paternity is usually pretty accurate. Like if you go all around the world and you do genetic testing on kids and you say, is the father really the long-term partner, spouse, whatever of the mom? About 95% of the time, paternity is accurate. It doesn't matter where you go in the world, some jungle village in Malaysia, New York City, it's the same. Paternity is accurate. Human dads, for the most part, tend to stick around and help. Either they help, by changing diapers and actually taking care of the baby, or they provide resources, but one way or another, they help. Humans have most of their sex recreationally. They go all through the cycle, whereas most animals are only interested in sex when the female is in heat. Right? These things make mating behavior in humans like extremely rare across, if we look at our mammalians cousins, very few have that. And it's very rare to take care of children.
So these characteristics are unique to humans.
These are, not entirely. You've probably heard about like these penguins, for example, that rear the young together, and you've probably seen the nature movie where the egg is on the feet and they take care of it. So I'm not saying it's absolutely unique to humans, but the human situation is really, really unusual. Part of the reason it's unusual is because human children are unusually useless, right? There's no other animal except a human where a 5-year-old can't make its way in the world. Only humans. You need your parents. When you're 5, you need your parents. If you're an elephant 5-year-old, if you're an orangutan 5-year-old, if you're a mouse, well, you don't live till 5-year-old, but this is a unique human thing. So what that means is that whereas an orangutan mom can take care of her kid by herself just fine. Doesn't matter that the dad wanders off into the forest and doesn't help at all. For humans, it really matters. Parental contribution really matters. So long-term pair bonding really matters. And this is a really long, circuitous kind of answer about love. So if you're going to say, well, why do we have love? And is love something central to being human? I'm going to guess and say, yeah, our first Homo sapiens 200,000 years ago in Africa probably had love too, because they had the biological situation that made it so that you needed to have long-term pair bonding to help take care of kids and help the genes that you got into the next generation survive long enough to be viable. And then you sort of think, well, why is that? Why are human kids so hopeless, so helpless, compared to other animals? Well, when a baby is born, its brain is about 400 cubic centimeters in volume.
How big is that?
Well, so, about like my fist.
Okay.
Right? And an adult brain is about 3 times that, 1,200. So you got to go from 400 to 1,200. We need big brains to be clever. Humans are pretty clever compared to most other critters. And so you might just say, well, all right, like why not just make the birth canal bigger and give birth to a baby with a really, really big head and then have a childhood that's not so protracted. But the problem, we think, is that in order to do that, you couldn't have women walk upright anymore. In other words, the hips would then get too messed up to walk upright.
Right, it would probably bring the front of them down. It'd probably be almost a quad pedal or whatever it's called.
That's right. So probably upright posture limits the degree. As it is right now, human childbirth is really difficult compared to childbirth in most animals. There are very, very, very few animals that regularly die in childbirth. Humans are one. Hyenas are another, because hyenas give birth to something called a pseudophallus. The females actually have something that looks like a dick, and their vagina goes down through the middle of it, and they give birth through that.
Wait, what? Sorry, David, I have never heard this. Bring up a little bit of that.
There's a good picture of the outside of it dangling down there.
Oh, dang. And that's on a woman?
And that is on a woman.
Wow.
That's right. So the hyena, you don't want to mess with a female hyena. Well, you don't want to mess with a hyena generally. But female, the whole reason I got to hyena genitals, which is a weird thing to talk about. I mean, you probably didn't think we were going to talk about that when you woke up this morning.
I did not at all. Here we go right here. Then there's an image of it.
So female hyenas give birth through this pseudophallus. And it's really hard, not surprisingly. Just think it's like, pushing a potato through a hose or something like that,
yeah,
right?
I couldn't do it.
And female humans, it's not as bad, but still, giving birth is super crazy dangerous. And women die in childbirth and babies die in childbirth, and you need to do C-sections and all kinds of crazy stuff happens. This is not a normal thing if you look in the animal kingdom. Most mammals give birth just fine. There aren't so many problems. We have that problem because even giving birth to that 400 cc brain is like right on the edge of being possible for human women.
Oh, that's pretty fascinating. So even that, down to the millimeter, centimeter of it, it's very precarious.
Yeah, it's very precarious. And
precise. If you look at it.
Things have to go right. There's all kinds of ways for things to go wrong during childbirth, as women will tell you, as OB-GYNs will tell you. And to get back to love, right? So then now you got this 400 cc baby that is hopeless, right? And in order for the brain to mature, that takes 20 years. I mean, that's a ridiculously long amount of time. That's a really, really, really long childhood. So maybe you can make your way independently, before 20, but not that much before.
Right, and you
20.
need support.
And you need support. And so to have a social system that promotes that, that's where love comes from, to get all the way back to your question.
Yeah.
Yeah.
And that could be love, from your parent. It could be love that even comes from a society. It could be, that love could then be in different forms, kind of.
Well, absolutely right. In the sense, so yes, we can talk about romantic love, which is the kind most of us think about, but there are all these other important kinds of love. And to some certain extent, it actually does reduce to that. It reduces to getting your genes in the next generation. In other words, we're most attached to the people we share a genetic history with. And as a society, we are too. Like, I'd be willing to speculate. If you look in Europe, in Northern Europe, like in Finland and in Sweden and Norway and places like that, those are the places that have the most socialist economies. Well, people share, taxes are high, people share the most with each other, and people are pretty happy to do it because they see their neighbors and the people around them as being fundamentally like them. You go to the United States, you go to Southern Europe, we're more of a melting pot, right? People don't necessarily
want to
share. And I think the reason is because people don't see their neighbors as being as much like them as they do in a place like Finland, where all 5 million modern Finns, came from 1,200 founders who came, whatever, in the year 800 or something.
Right. And I think that kind of makes sense, like that there's something inside of us where you feel safest taking care of your own. Is that what you're saying, kind of?
Well, you would like to think, well, we're all brothers, you would like to, in a lot of the world's religions, certainly Christianity has this idea, you should help everyone, you should share with everyone. In practice, though, people are most likely to help people who are like them.
Yeah.
Yeah.
And and that goes down to our DNA.
It goes down to our DNA, and it goes down to the way we divide people culturally. Yeah.
Yeah. At a scientific level, why do you find someone beautiful? Like, is it only visual? Most fellas enter the room wiener first. You know that. Knock, knock. Who's there? Wiener, baby. You know it. And Blue Chew is helping. Blue Chew isn't just a tablet. It's a cheat code for your crotch. Stronger, harder, longer, lasting. Like someone gave your downstairs a pep talk and a gym membership. Blue Chew is the original brand offering chewable tablets for better sex. That's the truth. And guys, it isn't just about performance. It's about legacy or third legacy. Give her group chat something to talk about. When you lay it down, they're talking about how it gets up. Bang, gank, 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 cock. Nothing makes you more of a legend than a little bit of Blue Chew. Discover your options at bluechew.com. And we've got a special deal for our listeners. As always, get your first month of Blue Chew free when you use promo code Theo at checkout and pay $5 for shipping. That's it. Join Blue Chew's mission to upgrade humanity one thrust at a time. Head to bluechew.com for details and safety info. And big thanks to Blue Chew for sponsoring the podcast. This is an ad by BetterHelp. Workplace stress is now one of the top causes of declining mental health, with 61% of the global workforce experiencing higher than normal levels of stress. We all feel it. Most of us do anyway. The constant need to keep going, to keep figuring it out, to create more, always on call. We're all that way. To battle stress, most of us can't wave goodbye to work, but we can start small. That's where BetterHelp comes in. BetterHelp. With over 30,000 therapists, BetterHelp is the world's largest online therapy platform, having served over 5 million people globally. And it works. With an app store rating of 4.9 out of 5 based on over 1.7 million client reviews. And it's convenient. You can join a session with a therapist at the click of a button, and you can switch therapists at any time. As the largest online therapy provider in the world, BetterHelp can provide access to mental health professionals with a diverse variety of expertise. Our listeners get 10% off their first month at betterhelp.com/THEO. That's betterhelp.com/Theo. At a scientific level, why do you find someone beautiful? Like, is it only visual?
Well, that's a good question. I mean, obviously, it's not just visual, but vision is the dominant sense through beauty. So obviously, people are attracted to voices, right? And of course, that's something, it's not a universal, it's a cultural thing. Like British guys come to the U.S. to get laid because American women hear a British voice and they just, they want to, some British guy could say, "Oh, fuck me on the floor."
Yeah.
Actually, I guess I'm doing a Scottish guy, but
that's fair, dude. Well, the Scots,
right.
the Scots will do anything on the floor, first of all.
But, and it's just, we love British accents in the USA.
Come colonize this vagina type of thing.
That's what, this is a thing. So obviously voices can be attractive too, but yeah, visual is really important. Smell is important. I know you were talking about this with Huberman, right? Weren't you talking about the dirty T-shirt experiment?
He may have mentioned it. My brain falls off sometimes.
Well, But yeah,
I'm just wondering, is there, what elements go into that attraction, that feeling when you find somebody, I guess attractive is more the kind of what I'm looking for instead of beautiful.
I think really the main thing it gets down to is we're attracted to people who seem like if we were to mate with them, we would have children that would be likely to thrive and survive. So the most attractive faces are the most symmetrical faces. People who have smooth skin are more attractive than people who have mottled skin, right? And there are various other things that go there. In other words, things that signal fitness, and I don't mean fitness in the sense of like going to the gym. Mm-hmm. I mean fitness in the sense of being able to survive and get your genes into the next generation, sort of the Darwin way of saying the word.
Yeah, I guess that's
fitness.
what I mean.
Those are the things we find beautiful. When you're saying I find someone beautiful, most of the time you're saying, yeah, you look like somebody who would be good to mate with and have my children with. Mm. And the thing is, if you're gay, you still have that feeling even if you're not making children with people. In other words, that's such a fundamental human thing about attractiveness that these fitness signifiers like being symmetrical, having clear skin, being tall, being well-muscled, these sorts of things are, things we find beautiful, even if you aren't thinking about mating with that person.
Are there any scientific differences between straight and gay people?
Well,
does that question make sense, kind of?
Yeah, no, it's a fundamental question, and so, let's approach it a couple of different ways. So, one way you could say, well, how much of the trait of who you're interested in sexually is heritable? Do you inherit it from your parents?
Okay, so heritable means you can inherit it from your parents?
That's right.
And you can pass it down?
Yeah, okay. That's right, exactly. That's right. So, eye color, for example, is something we well understand that we inherit from our parents.
Got it.
Your mom's got this, your dad's got this. But most traits are not so defined that way. They're only partially heritable. They're only partially determined by the genes you get from your mom and your dad. So sexual orientation, turns out it's actually different for men and women. The best estimates for genetic studies are that sexual orientation in men is about 40% heritable, and in women, it's about 20% heritable.
So that means you could pass down gay from an adult to a child?
You could pass down gay or straight or bi or whatever you happen to be.
Really?
From a parent to a child. But keep in mind what these numbers are. Like 40%, that's only 40%. That's not the whole story. That's still leaving 60% that you're not getting from the genes you inherit from your parents. But that still doesn't mean that 60%, part of that isn't biological. It's just not heritable. So, for example, we know that women who, for various different reasons, were exposed to testosterone in the womb or as they were young, because the adrenal glands secrete testosterone. There is a disease called congenital adrenal hyperplasia, which just means the adrenal glands get big and they secrete a lot of testosterone. So women who have that can be slightly masculinized in their appearance sometimes, and they're way more likely to be into other women sexually, right?
Which makes sense because you have more testosterone.
That's right. So that's not something you're going to pass down to your kids.
Got it.
But it's a biological way in which your sexual orientation can be affected.
I see. So that's an example of a biological way.
That's a biological, biological is the whole thing. Biological means the hereditary stuff, the heritable stuff, and the non-heritable stuff that's also biological.
Got it.
And then, so you might say, well, what about how your parents raised you? Here's something that, to me, is shocking, right? There was this major study done by the American Psychological Association to say if you are raised by gay parents or straight parents or a single mom or two parents or you're religious or non-religious or you're politically this way or that way, does it make a difference on how likely you are to be straight versus gay? The answer doesn't make any damn difference at all. It's unimportant. Now, it make a difference in terms of how willing you are to express it. Like if you grow up in a super religious family or any religious family where being gay is looked down on, you might not want to admit it. You might not come out. But it doesn't mean you don't feel it in yourself.
But so you're saying if a couple's driving a Subaru, they're not more likely to have a child that could be gay than somebody else?
No, they're more likely to have, if they do have a kid that's gay, they're more likely to have a kid that's comfortable with being gay as opposed to repressed about it and feeling like they can't express that.
I feel like
but there is, and this is, kind of surprising, right? You would, because people say, oh, parents are so important. Parents are important, but they're not important in everything. And whether you're gay or straight, parents don't have a damn thing to do with it.
Now, what if somebody's almost gay, right? They think about being gay sometimes, but they're not being gay. Are they I just wonder, is there a level of that kind of like almost gay where then the kid is gay? You know what I'm saying?
Well, so when you say the kid is gay, though, what do you mean? You mean
just the kid is?
To me, what I'm talking about is what do you feel in your heart about your own self?
Right.
What do you answer in an anonymous survey? Not when you're too scared to be in your school or your community or with your coworkers or with your family, but what's really inside you. Parents don't matter for that. Parents matter a lot, and your community matters a lot for, are you willing to admit it? Are you willing to come out? Are you willing to, bring your gay partner home to meet the folks? Their parents and community matter enormously.
Yeah.
Right?
Does nature, and this is awesome, and it's Pride Month too, so I'm glad that we're talking about some of this stuff.
Yeah.
Is being gay an abnormality to nature?
Well, let's put it this way.
And I don't mean negative abnormality.
Yeah.
I just mean, is it something unique to nature? Or is that the right term?
Well, I don't know what unique to nature is. Nature is everything we got. So, but I can tell you this, and you've probably heard this before. We're not the only animals that where there's same-sex sexual behavior, right? You can find in lots of different critters. What is true, though, is that if you look at examples, sheep are a good example, all right? Okay, some male sheep will mount other male sheep, right? Okay, are they really gay? Well, actually, they're bi. So it turns out when you look at critters and you look at same-sex behavior, it's almost never exclusive same-sex
so they're just having a good time.
Behavior.
They're in a frat. No offense, dude. And that's just
so that is somewhat different. But in terms of, is there can we divine a larger purpose for gay and bisexual behavior? People have theorized about this. They've theorized about the contribution of the gay aunts or uncles in helping to raise kids, the same way people talk about the grandparent effect, pitching in, whether that is really a true thing or not, I would say is still very much up in the air.
Interesting. That's a cool answer, man. Bring up the sheep again. That's really interesting. I didn't know this. Homosexual behavior in sheep has been well documented and studied. The domestic sheep is the only species of mammal, except for humans, which exhibits exclusive homosexual behavior.
Well, so that's contradicting what I just said. That's interesting.
A good point. I wonder if this is, but this is also Wikipedia.
But Wikipedia probably is more up to date than me. Sheep may be an exception, but if you look, I mean, there's a whole lot of different species that do have homosexual behavior, and for most of them, it's not exclusive homosexual behavior.
Okay. Go back to that again, actually, because I think a lot of what you're saying is in here. 30% of all rams, which are male sheep, demonstrate at least some homosexual behavior. One report on sheep found that 8% of rams exhibited homosexual preferences. That is, even when given a choice, they chose male over female partners. This documented homosexual preference has garnered much discussion. Such rams prefer to court and mount other rams only, even in the presence of estrus ewes. Anyway, it's interesting. I never thought about this or even talked about it with somebody, so this is pretty cool.
Well, so, I mean, I think the important thing here is that this is not just something humans came up with.
Right.
Right? It's not, and if you're trying to explain it as a moral failing, right, as many religions would, well, you would have to say, well, it didn't start with us.
Right.
Pete Buttigieg says, had a real good quote, and I'm paraphrasing him, and he was saying, I've been felt gay as soon as I had any sexual feelings whatsoever. It wasn't a choice.
Yeah.
If your quarrel with me, Mike Pence, is not with me, it's with my creator. I got made gay. I was born that way.
That's a great statement, huh?
Yeah. No, I think it gets to the heart of the matter. Like if you ask a straight man, when did you decide to be straight?
Yeah.
No guys go, oh yeah, I was thinking about it and I was weighing the pro and cons and I was like, well, all right, you got pussy over here.
It was February.
Well, and so yeah, okay, I kind of came down like I'm going to be straight. No guy ever answers that way.
You're right. Oh yeah, I think that's pretty ridiculous, and I think that to me it doesn't feel like that would be a moral thing. I just wonder. I wonder sometimes, does nature? Because nature, I guess I always look at it as male and female needed to reproduce to keep like existence happening, right? And so then I wonder, at some point, does nature need more like gay energy? I just in the you know what I'm saying? I just don't know sometimes like what nature's plan is, I guess.
Yeah. Well,
and I guess it's TBD, some of it.
A lot of it is. Yeah.
Is love scientifically quantifiable?
Well, it kind of is. In other words, certainly new love is, right?
New love.
So if we take people who are in that like obsessional, first 6 months, like, just crazy about you phase.
Fucking drooling your eyes.
And we put them in a brain scanner and show them a picture of their beloved, right? And then we image it and we look at what do we see? Well, we see that there's this part of the brain that's part of kind of the pleasure and reward circuitry. That lights up. That's and Huberman was talking about this. It's called the dopamine neurons of the ventral tegmental area. So they light up, and then we also see the prefrontal cortex of the brain, the part of the brain that's really involved in making careful, reasoned, rational decisions. That's like turned way the hell down. So what that means is like, think about this in terms of your own subjective experience of being truly, madly, deeply in love. You're going like, oh yeah, she's so great. And that sore on her lip will clear up.
Yeah.
Right? Yeah. And the other thing that happens, there's this part of the brain called the amygdala that's very involved in fear and feeling under threat. And that's also turned way down, even below normal.
Wow.
Right? Because you feel very comfortable. You feel very safe. So the interesting thing, right, is so this study was done with people who were in that truly, madly, deeply early phase.
Yeah.
So then you go to old married people who've been together for a real long time, and you ask them, you say,
"Oh, watchy."
Do you do you feel the same way about your partner as you did when you first met? And 19 out of 20 people will say, well, no, right? It's not that same crazy, passionate, wonderful, obsessed, got to have sex every minute thing that when we first met. It's sort of settled into a more mature, loving, kind of respectful sort of thing. But 1 out of 20 people will say, no, it's just as intense, just as passionate as always was. And I know when I heard this, I said, you're lying.
That's what I thought. This person's crazy.
Well, not just lying, they're full of shit.
Yeah, and they're pervert. They're probably
maybe they just want to
swingers.
appear a certain way.
They're swingers, David.
But they're saying this about not their piece on the side, but their long-term partner.
Got it.
And so, what happens when you put old married people in the brain scanner? Well, the 19 out of 20 people who say no, it's not the same way it was when we first met. Their amygdala is not turned down. Their prefrontal cortex is not turned down. They're seeing their partner in the cold, clear light of day with all their rational faculties. But that 1 out of 20 people that says they are truly, madly, deeply still, the brain agrees with them. In other words, their brain scan looks like someone feeling new love. And now, what do these people have that most of us don't have, and how can we get it? We don't know. Be good to bottle that.
Yeah, gosh. I'd do a couple grams of it right now, dude. I wouldn't say anything. I'd eat it. I'd put a pill under my tongue and let it, I'd do a half an 8-ball of it right now and take you to a damn Sphere show of the Grateful Dead. It'd be fun. Yeah, I think love is something that certainly gives us a sense of purpose, I think,
Absolutely.
Do you feel like humans these days, we talk a lot about purpose on here. Do you feel like humans these days that we're losing that we're losing a sense of purpose? That's what it feels like sometimes to me.
Well, certainly there are fewer and fewer people who are involved in relationships, and fewer people who are living together, and more people who are living alone. And the people who are living alone aren't always replacing a romantic partner with lots of time with friends. A lot of times they're replacing it with, the internet, with watching podcasts like this. Not to disparage podcasts like this, but what I'm saying is not the same. Right?
Yeah.
So, I think there is a crisis of connection that people are feeling right now, and I think it is something to really, really be concerned about.
Why do you think it's so important for the human brain or humans to seek meaning in life?
I think we can't help but do it. I think our brains are hardwired to take fragments of information and then try to make a story out of them. We are a story-making, storytelling species. We can't help but do it, right? It is a deeply human thing. And let me tell you a little bit of what I mean, right? So people say, well, science and faith are somehow in opposition. I say science and faith are two branches of the same human stream. We're starting with fundamental questions that we can't know. What is our purpose? How did we get here? How should we live our lives? What happens after we're gone, right? And faith takes one path. It says, all right, I've got an explanation for doing that. It involves the divine, and I will believe that, and that is my way forward. And so science says, well, I'm going to address those mysteries in a different way. I'm going to do experiments and observations and subject those to falsifications, and I'll take some wrong turns, but I'll fix them, and eventually I'll get closer and closer to the truth. And they are two different ways of getting at it, but they have the very same root. We as humans are curious. We want to know what's going on. We want to put it together. We want to make a story. And it happens in the most basic sensory level. Like if you're walking through the woods and you hear, you can't help but imagine that someone's coming up behind you, right? You're making a story in your mind about what those sounds mean. Our whole brains are built to take fragmentary information and put them together in a story. It's the most fundamental human thing there is.
Why does it feel that science is always trying to defeat faith? Does it make any sense?
Well,
I just thought, and maybe not always, maybe that's not true. I don't know, that just popped in my head.
Well, I mean, certainly that's the way that a lot of people think about it. I mean, there are certain aspects of certain faith stories where science will weigh in. In other words, if you say, I believe the literal Bible that the earth was created 6,000 years ago by God, well, scientists will say, we got some observations that say it's been around a lot longer than that and it didn't happen that way. And so, we have a problem with that.
Yeah,
but
science is going to be like, hold my degree, yeah.
Yeah, but, when you look at it, a lot of faiths don't really have as much of a quarrel. I mean, there are some people who are really fundamental literalists, and they're going to say, no, that a Bible story about 6,000 years is right, and if you scientists disagree with me, well, then we got problems. There's really no way to reconcile this. But like if you look at the Catholic Church, right? So, the popes say, well, all right, that Old Testament stuff shouldn't be taken entirely literally. We've got astronomers. The Vatican actually sponsors some scientific research, and you can be a person in the Catholic faith and you can believe in God and you can believe fundamental aspects of the credo of the faith and still be all right with the scientific model of the Big Bang or evolution or humans being 200,000 years old.
Bring this up really quick. I do think this is interesting. Let me take a peek here. The Vatican supports research through various initiatives, most notably the Vatican Observatory and the Pontifical Academy of Sciences. Wow, that's where Harry Potter went, I think. The Vatican Observatory conducts research in astronomy and related sciences, while the Pontifical Academy of Sciences promotes advancements in various scientific fields. The Vatican also supports research into stem cells, rare diseases, and other areas. Huh.
That's right. So this is an example of a major branch of Christianity that doesn't have like a fundamental basic problem with the scientific method. And it's not just Christianity. Like, for example, if you were to look at Buddhism, the Dalai Lama, our present Dalai Lama, says, yeah, I'm really interested in science. If science conflicts with Buddhism, then Buddhism's going to have to change a little bit. We're going to have to adapt. And so, you can be a Buddhist and you can live according to Buddhist principles and still have a scientific worldview and respect science and believe in the scientific method. These things aren't at their core irreconcilable.
Excellent. Yeah. Thank you so much, man. I think a lot of people need to hear stuff like this because I think, especially that last piece, it was like, you can do both of these things.
You can.
I think there's a lot of people who get stuck in the word of like, well, if I don't do exactly this, then God's not going to love me or God's not going to care about me. Or if I even imagine, like I remember it felt like sometimes when I was young in certain environments that if you even like neighbors that I had and stuff, if they even had like an imagination that it would go against some of their beliefs that were like really iterated strongly in their household, right? And no judgment against that. Those beliefs may have kept them into a pattern that was safe and great for them, right? And it may do that for millions of people. But I do think it's just interesting how do you manage both? And I don't think that God would let us have these thoughts if we weren't supposed to have these thoughts,
He gave you the hardware to have those thoughts. You're absolutely right. Like Pete Buttigieg said about being gay, ultimately this goes back to my creator, not me.
Bring it up, PDB. I want to see exactly what he said, man. Start it over, go on.
You may be religious and you may not. But if you are, and you are also queer, and you have come through the other side of a period of wishing that you weren't, then you know that that message, that this idea that there is something wrong with you, is a message that puts you at war not only with yourself, but with your Maker. And speaking only for myself, I can tell you that if me being gay was a choice, it was a choice that was made far, far above my pay grade. And that's the thing I wish the Mike Pences of the world would understand. That if you got a problem with who I am, your problem is not with me. Your quarrel, sir, is with my Creator.
And did Mike Pence directly attack him, or was that some of that could be political kickballing? I don't remember exactly, but either way, I think that's it's an important thing to hear, you know?
I think it's a very important thing to hear. And to me, like, the interesting thing when we talk about faith is, what does it mean that you find faith everywhere in the world? In other words, if you talk to the anthropologists who go all around the world and, studied every society all around the world, there isn't a single place that doesn't have some kind of supernatural explanation.
Amen.
Right? And
that's
they can
pretty
be
fascinating, right? Now, that's something that also makes us unique. Is it?
Well, who knows? I mean, if there's chimpanzee religion, how would we know?
So even animals could be in heaven. Dude, if I get to heaven and there's a bunch of mosquitoes up there, if their beliefs, that's gonna piss me off.
I had an advisor when I was an undergraduate and I worked in a lab, and he said, I had a bad dream last night. And I said, Joe, what was that? And he said, this is a lab where we work with rats. And he said, I had this dream that I died and I went up to heaven and I met St. Peter and he had pink eyes and little whiskers.
Oh, damn.
I was like, oh no, I'm in the shit now.
Maybe he had conjunctivitis. Who knows what he had, huh?
That's right.
Maybe he had a long Saturday night, huh? Oh, dang. So even animals.
Well, I don't know. Look, I'm not going to tell you that chimpanzees have religion. I'm just saying that if they did, it wouldn't be something that it would be straightforward for us to know. I mean, the fascinating thing is that it's a human universal. In other words, not everyone is a person of faith, but everywhere around the world, every single society has people of faith. And
it's pretty cool, though. Think about how cool it is.
Well, so it can't be an accident.
Okay.
Right? It's like, this fulfills some fundamental human need to have these ideas. And, if we talk about mortality later, I can tell you about a particular theory I have about that. We don't have to get into it now.
So David, that leads exactly to kind of what I was thinking about. My next question is, how does our quality of life affect our beliefs about death or the afterlife?
Well, I think this is something where neuroscience actually has something to offer.
Okay.
Right? So when I first started studying the brain, 40 plus years ago, I was taught, well, the brain just kind of sits there and it waits to react to something. Something comes in your senses, you hear something, you see something, your brain does something, and then you move your muscles and you respond to it. And that's what it is. The brain's kind of sitting there waiting for something to happen. It's a reactive organ.
Like a two-stroke motor or something.
Right. And well, even not like a two-stroke motor that isn't even started yet. That's waiting for someone to pull the ripcord, right, for it to start up. And what we now know, the modern conception of the brain, is that when you're just sitting there spacing out, your brain is really busy, and it is a prediction machine. Your brain is trying to figure out what's going to happen next in the near term. It's doing is that person who's walking up there friend or foe? Am I likely to be hungry lately? Oh, I see those French fries. Should I secrete some saliva of the type that's particularly good for breaking down starch, or am I going to eat meat? And so should I secrete this kind of saliva that's particularly good for breaking down protein? All of these are examples of where our brains and our body working together are trying to predict stuff in the near term. Well, what does that mean? It means that our brain is wired to presume that there will always be a near term, that there will be a future, right? And so, I got diagnosed with terminal cancer. I was told 4 years ago that I had 6 to 18 months to live. And, of course, that was really upsetting and I was freaking the fuck out about it. in addition, I could do practical stuff. Oh, I better write my will. I better have this conversation with my kids. I better, make sure this is done in the house and like these letters are written for my students, so them to go on the next part of their career, like
Better
all that
fix
practical
that window
stuff.
screen.
Right, exactly. And, but in terms of actually deeply engaging with myself not being there anymore, with my own demise, I felt like, I was skittering across the ice. I couldn't really dig in and grab it. I couldn't really think about what it's like for me not to be there anymore. And I thought, well, is this a personal failing? Do I just suck? And I thought, well, maybe, but I mean, I do, but
we all do.
But, what I'm thinking fundamentally is that this is not something that we as humans are designed to do. Our brains are hardwired to predict the near future, which presumes that there will be a near future,
yeah.
Right? And so if you extrapolate this a little bit.
And what does extrapolate mean, just so people know?
I'm sorry, if you kind of move on to the next step,
okay,
right, of what this means for faith, right? If you go around the world, nearly every, not absolutely every, but nearly every religion in the world has an afterlife or reincarnation story. Very few religions, Judaism is one, you're dead, and there isn't actually a story about what happens after you're dead. But almost every other one does.
Or the big invoice.
You go to heaven, you meld with the divine, you're reincarnated, but there's something that happens. Yeah. These stories are exceedingly popular all over the world in all cultures. Well, I think that the reason they are is because of this brain bug we have. We can't imagine ourselves dead because our brains are hardwired to predict the future. And that's why we have these afterlife and reincarnation stories in faiths all over the world. And so I have total sympathy for these, not just because I'm diagnosed with terminal cancer, because I see them as something deep and fundamental to what it is to be human and something that binds us all.
It's so funny, man. My next question is, why is it so hard for us to think about our own deaths?
Yeah, well, we got there. You got my answer. Yeah,
and it is funny because I'll start to think about it, right? And at first I can think about, okay, you're going to die, right? I can think about the certain, like the mechanics of like, okay, I'm in a hospital bed and I'm laying there and someone's holding my hand, all of that. The part where I start to like, it almost like makes my soul like, it's like when you're not going to exist.
Yeah.
That's the part my brain, it won't accept that. It's like, well, what do you mean I won't exist?
It's a very hard thing to deal with. And,
Do you think it's a clue?
Yeah, I don't know if it's a clue or not. I mean, for me, in sort of dealing with my terminal cancer diagnosis, it's like, for myself, I'm 63 years old. Yeah. Well, I mean, yeah, I would love to have 20 more years or something like that. That would be great. But I've had a really good life. I got no complaints. I've got a terrific wife.
Yeah, you got to be in love.
I got great kids. I've gotten to be in love. I've gotten to do good work, have good friends, have adventures, do the things I want to do. I got to have a job where I don't have a boss and follow my own curiosity. Oh. Almost no one gets that, know. So, like, I've had a really good life. And when I think about not being there, it's not so much, I do want more of it. That's not the first thing. I think about my family.
Yeah. Yeah, man.
I don't want to leave them. I don't want to leave my wife. I don't want to leave my kids. I don't want to leave the people who are close to me. That's the part that gets me fundamentally. Not like, oh shit, I wish I could have 20 more years of partying.
Yeah, yeah, for sure, yeah. Yeah, I mean, yeah. I mean, I wouldn't mind listening to a couple more Grateful Dead tunes, in between loving my family.
Are you a Deadhead, man?
I just got in them in the past year and a half, man.
Really? Oh, so a nouveau Deadhead. All right, okay.
But no, what's so funny, David, and thank you for sharing that, man. You know what sometimes makes me, like, I guess I don't know if it's lame or whatever to say, but like sometimes I feel like I could never let certain people know how much I love them, you know?
Yeah.
It almost feels like it's not even physically possible sometimes to let like if I did, the cops would have to, like, you almost like, you know what I'm saying? Like, it wouldn't be a perversion thing, but it would be like, hey, you can't loiter on my porch anymore. It's like, sometimes it feels like a feeling that's so impossible to completely share, like to let your kids know how much you love them. Like, you probably could never do it.
Yeah, I don't think I could. I mean, for me, I do struggle with that, but I struggle with it less for the people I'm really close to, who I think I'm pretty good about telling them how I feel.
Right.
I think my wife knows how I feel. I think my kids know how I feel. I think, my friends, my colleagues, who I love deeply, I don't think, it's harder for that. It's harder for me to, go to my best work buddy and say, dude, like, you don't know how much I love you. That would be a little weird, right?
Yeah, that's what I'm saying, dude. It's hard to express some things without becoming an HR issue.
That's right.
So I think that's sometimes, and I don't know if that's scientific or not, but love sometimes gets shut down by the HR department.
And I think more in men. Yeah, I think men have a harder time with this. Yeah.
But it is funny that's the one feeling sometimes for me. It's like, I almost, you couldn't put together how much you love somebody or something, or somebody, you just couldn't put together how much you love somebody. It's like you can't, I don't know, love is this thing. It's so hard. It's like, I don't know. To me, it's just it's such a fascinating energy.
It is. And, it's remarkable to think that something that profound ultimately originates in this biological imperative to mate.
Right.
Right. And even though this love, translates into situations that don't have anything to do with, making babies or whatever, it generalizes, that's where it came from, and it's easy to think, oh, well, like it must have come from, something like this deep wellspring of mysticism. But, I don't know that it means that. It can be that transportive and that surreal and that important and still be fundamentally natural in the end.
Like a teammate of the reproductive process.
Yeah, you go, oh my God, I'm so in love. Well, why is that? Well, ultimately get your genes in the next generation.
Yeah. Well, it's kind of interesting because even this kind of moment is a little bit of that, faith and science. A little bit of that, there's some mysticism.
Yeah.
And then there's some science, right there with it. Is pornography causing a problem in your life? Do you find yourself watching porno for longer periods of time and having trouble stopping? Is porn affecting your relationship or dating life? Well, you're certainly not alone. Watching pornography has become so commonplace today, and oftentimes men use porn to numb the pain of loneliness, boredom, anxiety, and depression. Shame and stigma prevent men from talking about these issues and getting help for them. I want to introduce you to my friend Steve. Steve is the founder of Valor Recovery, a program to help men overcome porn abuse and sexual compulsivity. Steve is a long-term sexual recovery member and has personally overcame the emotional and spiritual despair of abusing pornography and has dedicated his life to empowering men to do the same. Steve is an amazing person, and he is a close friend of mine. I mean that. Valor Recovery helps men to develop the tools necessary to have a healthier sex life. Their coaches are in long-term recovery and will be your partner, mentor, and spiritual guide to transcend these problematic behaviors. To learn more about Valor Recovery, please visit them at www.valorrecoverycoaching.com or email them at admin@valorrecoverycoaching.com. Thank you. Man, thank you so much, David. We're not done, but I just want to say thank you, man. I just appreciate it. I think it's, one of the things I feel so lucky about this job is just that I get to have, I get to have moments with people sometimes that mean something, and it's nice.
Yeah, I'm very, very happy to be here.
Yeah, I really appreciate it. Let's talk about a little bit about individuality because, well, for one, you have a book actually. Yeah, there it is. The New Science of Human Individuality.
Know it, be it, live it. Buy it for your friends.
Okay, know it, be it, live it. Buy it for your friends right there. You can get it online, right? And we'll put a link below in our YouTube video. So let me just start with this. It's kind of just a very basic. Are our fingerprints the only thing that makes us individual?
No, there's all kinds of things that make us individual, but I love fingerprints. Let's talk about fingerprints,
okay.
Right? So identical twins, and actually I hate this term identical twins because they're not really identical, but genetically identical twins. The science term we use for it is monozygotic twins. It turns out they don't have identical fingerprints.
Oh,
right.
Really?
Yeah,
I've never believed in twins.
Yeah, this is an important thing for like solving crimes.
Right.
Right? You can imagine a mystery story. No, my identical twin did it. Well, no, he didn't, asshole. He has different fingerprints than you.
Yeah, I've never trusted twins that much.
Oh, I have twins.
Oh, you do?
Not identical twins. I have boy-girl twins.
Oh, I'm willing to at least hear about that.
Fingerprints are something the statistics of fingerprints, like how many ridges you have, that has a heritable component, meaning, that is partly determined by genes you get from your mother and father. And so if you have an identical twin, you're probably going to have the same number, but the exact precise pattern, exactly where the whorls and swirls are on your fingertip, that is individually determined. And even genetically identical twins have different fingerprints.
Wow. So that's pretty wild. So that's saying that even in this moment where there's a lot of replication, I guess, between twins, that even there, each one has a stamp of uniqueness to them.
Yeah, and I think this brings up something that's super, super crazy important. And it brings up, have you known some so-called identical twins in your life?
Yeah.
Yeah. And so they're not really identical, right? In other words, like you can look at them and you can tell them apart and they don't have the same personalities. And even if you met them as newborns, they wouldn't truly be identical down to the last hair and molecule and their temperament. Like one would cry more, one would be more calm, one would be more this way. Interestingly, this is a tangent, right? People study this a lot in armadillos.
Huh.
Because the 9-banded armadillo, they are born every time as identical quadruplets.
Wait, so there's the 9-banded armadillo. Every time that they're born, there's 4 of them.
There's 4 of them, and they're 4 genetically identical ones, and it's coming up on your screen.
Wow, why?
Yeah, and so, like, if you take 9-banded armadillos, and like, so you can do stuff with armadillos you're not going to do with people, like dissect them and look at their organs as soon as they're born, and like you'll see, all right, these are genetically identical critters. But one of them's got a liver that's 50% bigger than the other. The other one's got like a spleen that's different than this one. They're not really identical even at birth. Well, so how did that happen? Well, they got the same DNA, and they grew up right next to each other in the same womb, in the same mom. So how did they get different even when they were born? Yeah. And the answer is this. It turns out that the DNA is not like a blueprint. It's not like a wiring diagram for the body and the brain that absolutely specifies everything. It's more like a really vague recipe, right? That says, like if we're imagining this for the brain, instead of saying, hey, neuron number 1,407,000, grow a little bit towards the top, and then after 4 millimeters, make a left turn and go across the other side of the brain. No, it doesn't work that way. It isn't a wiring diagram. It's more like, hey, you bunch of neurons over there, about half of you cross over the other side of the brain and half of you keep going. And in one identical twin, maybe 40% will cross over and another 60%, on average 50% do. But even in genetically identical animals, the variation in how they develop gives rise to individuality.
I see. So you're saying it's not like a dictator. It's more like a crossing guard, like you this way, you
That's
guys
right.
that way.
It's like, so there's this guy in Ireland. His name's Kevin Mitchell. He's a neurogeneticist.
Does he seem like a neat guy?
And he is a neat guy. And so Kevin Mitchell says, if I were to make 100 clones of you and they grew up, they wouldn't be 100 Theos, they'd be 100 individuals, each with their own experience that developed in different ways. And not just because they had different experiences from you, even the 100 baby clones would already be different because the way they grew in the womb isn't exactly the same, isn't 100% specified by the DNA. Right? And so this is some of the way we say, well, how do we become individuals? Well, some of it is what you inherit from your parents in your DNA. And some of it is other biological stuff like, what hormones were flying around when you were in utero or growing up. And some of it is your experiences in the world. And then some of it is this fundamental randomness of development that I just talked about, what we call the stochastic nature of development in science speak. Well, that's a fun word, isn't it? Yeah. Stochastic. Say that at the, tonight and impress your friends. Huh?
Yeah. I don't want to just go back to fingerprints on this, but to use that as a marker for individuality, could someone throughout time even have had the same fingerprints? Do we know? Like, do we know if someone else in history could have had the same fingerprints as you, like back throughout time?
Oh, that I don't know. In other words, I don't know if there's so much, if patterns get repeated. I mean, I think if so, the answer is not very often. I mean, otherwise, the fingerprint databases that all these law enforcement groups have would be worthless. Sometimes in groups that are very genetically homogeneous, you walk down the street and you feel like you've seen the same face. Like I spent some time in Finland. All 5 million Finns came from like 1,000 founders. And you walk down the street and you go, see that dude. Like 10 people later, you go, is that the same guy or is that your brother? Or like, what the hell? That's the same face again, right? Yeah. So there's some groups that had so few founders that there actually isn't that much genetic variation, right?
Oh, try to pick out of a police lineup in Finland.
Yeah. Now, of course, maybe I'm just being racist against Finns, and the Finns would say, "Well, no, right?"
But why does nature make us so individual? I wonder. Like, why is that important?
Well, so there's a couple of levels of that. One way to think about it is the way that individuality starts is by sexual reproduction. In other words, when you are the mixture of your mother and your father, then you're stirring the pot and making a new mixture, and that makes individual you, right? Not all animals reproduce that some way. Some animals just split and they make genetically identical copies of themselves. They make clones. And you might say to yourself, well, that's easy. Like, why doesn't every animal just split and make identical copies of themselves? And the idea behind this is that if you are constantly mixing and recombining, as you do with sexual reproduction, then you're getting a population that has more different traits vary. Maybe this person is a early riser and this one's a late riser. This one can tolerate heat, this one can tolerate cold. And so if a disaster happens, you're less likely to kill off the whole population. So in populations, genetic diversity is good. And sexual reproduction, as opposed to just splitting yourself and making a clone, doesn't get you that diversity. Interestingly, there are some animals, like there are some insects that can reproduce both ways. They can reproduce sexually or they can split themselves.
Really?
Yeah. And in times of plenty, they tend to do one, and in times of lean, they tend to do the other.
Bring that up.
And there are plants that do the same way, like ferns are a good example. Ferns can propagate with runners and make clones, or they can propagate sexually and mix their genes and make individual mixed offspring.
Oh, hell yeah. Oh, ferns look like they've been partying if you just look at them. You know what I'm saying? It looks like
I know what you mean. If I'm going to come back as a plant, I think I want it to be a fern.
yeah.
Are those devil horns, or are you doing ferns in? No, see, this is the fern sign, right?
Oh yeah.
Yeah, this is the horns. This is the fern.
I'll do both, dude. It's like they've been at Ferning Man, dude.
Ferning Man.
Thanks for even.
That's comedy gold right there. Ferning Man.
It's copper, comedy copper. I'll go with. But thank you for even entertaining it. Yeah, go back to this. Let me see. Insects that can reproduce sexually and also through parthenogenesis, a form of asexual reproduction, include aphids and some species of stick insects. Huh.
That's right. That's right. So parthenogenesis is a term. It comes from Athena, the Greek goddess, right? Mm-hmm. Who sprung from the head of Zeus.
Yeah.
So the idea is that she didn't come from sex. So the word parthenogenesis, the reason where that word comes from is coming from that Greek myth, right?
Dude, that's cool.
Yeah. Yeah.
Wow.
Yeah. Interestingly, it's some animals that normally reproduce sexually. It's a very rare thing, but occasionally a woman's egg will actually start dividing in a way that it can actually make a whole embryo. And you can have a female that gives birth to an exact copy of itself. Dudes can't do that, right? Only females can do it. And
Female humans?
And that's called parthenogenesis. People have argued about whether it happens in humans. I don't know what the internet will say right now. When I looked into it about 20 years ago, some people were saying yes and some people were saying no. I don't know what the latest is on that.
And some people say that in addition that their fingerprint, that people's sphincters, like their butthole or beehole or whatever, that it is like the 11th fingerprint, some people say. Is that...
You know, remember when people would straddle Xerox machines and make photographs of their nethers?
That's the Christmas party.
That's right. That's right. Well, so that could be your scanner for the 11th fingerprint.
But can you look up if the sphincter, I don't know how you would even say that. While not considered the 11th fingerprint in any official capacity, the concept of the anus as a potential biometric identifier has been explored due to its unique characteristics. Historically, this is the only information I'm seeing here, the artist Salvador Dali is credited with having observed the unique nature of anal creases and comparing them to fingerprints. Huh. So this has been thought of before, you know?
Well, you know, it means, if you're undergoing anal bleaching, right, then you can evade the cops if they're using that as a way of identifying you.
I'll ride with that. We'll look at that more another time. But yeah, I've always heard that. Do we have nerves in our butt, right?
Oh, absolutely. Yeah. Yeah. Well, you know, you've got nerves in all your skin, but it turns out that, you know, in the places where people like to get sexy, you got a special kind of nerve. And so, you know, the lips, the genitals, the butthole, right? So these places aren't just random. They're a special kind of skin. And so for years and years and years, people said, well, how come you can have sexual sensations from certain places on your body, but not others? Like
that's a good point.
The back of your hand doesn't feel that sexy. End of your nose, not that sexy. But, you know, your genitals, sexy. Your lips, you know, maybe your butthole, sexy, you know. And so why is that? And nobody really knew the answer until there was a fundamental discovery. And it actually started in the 1850s. There was a German anatomist named Krauss, and he took sections of the skin of the penis and the skin of the clitoris, and he looked at them under a microscope, and he said, well, there's this one kind of little nerve ending, and it's kind of like wiggly like this, and it has a little capsule around it, and I see a lot more of them here than I do in other places in the body. And maybe this is the special nerve ending that makes sexual sensation.
Oh, that's interesting.
And people said, well, yeah, maybe, but maybe not. We don't really have a way of testing it. We didn't have a way of like specifically activating those ones and not other ones, turning them on or turning them off. And this was like a total mystery. But there were some things that really made it seem possible. So, all right, so like if we're going to talk about dicks here, like if you talk to most guys and you say, on your dick, what is the most very sensitive part of the dick? Well, most guys will say, well, like the ridge right around the head of the dick what's called the corona. That's a real hot spot. And the underside of the dick, particularly that kind of elastic tissue towards the bottom, is called the frenulum, is what the doctors call it.
Oh, yeah.
Right?
That baseboard or whatever.
Right. These are like the hottest, sexy hot spots on a guy's dick. All right. And it turns out that's where the very largest number of these Krauss corpuscle endings are. So, oh, well, that seems like likely to be true, but is it really true? But a couple of years ago, a buddy of mine named David Ginty at Harvard figured out how to specially label and then electrically turn on or turn off these endings in laboratory mice. And he proved that these really are the nerve endings that are involved in sexual sensation. And so—
Wow, mice are partying, huh?
Well, mice got what we got, right? I mean, they've got, mice have sex, mice have orgasms. They do what we do.
Yeah, and they're willing to be tested too.
Well, they don't get to say no.
I've never heard one complain, to be honest with you.
And so this brings up some things so people always joke about how young men come really fast. Right? Well, that's for a lot of different reasons and, being nervous, it being new and all that. But part of the reason is actually not just these Krauss endings, but all the different endings in your skin. From about 20, as you age, you lose about 1% of them every year. So you get less and less sensitive in your skin as you get older.
Why?
Yeah, well, we don't really know why. That's a good question why, but this seems to happen. It happens in humans. It happens in other critters. And so part of the reason why old guys don't come as soon and sometimes have a problem coming at all is because fewer and fewer of the nerve endings that trigger orgasm are there. You lose them as you age.
Yeah.
The same thing happens, interestingly, with nerve endings for pain. So you might have heard, for example, that old folks that are confined to bed get bed sores. Well, and you might think, well, why? And they get it from just laying in one position and wearing a hole in the skin. You would think, oh, God, that would hurt like hell. Why don't they just move to a different spot? And the reason is, as you get older, you not only lose the sexy nerve endings and the fine touch nerve endings, you lose the pain nerve endings too.
They don't feel it.
They don't feel it.
Wow. Yeah. I mean, that's why. Dude, even if I ejaculate or whatever, it's like a couple mealworms getting out of a sleeping bag, I mean, definitely things change,
Things change.
And my father was 70 when I was born, which is I just say that now because I never really thought about this. Could there be something different about his DNA or like genetics or something at that age? Could there be something at that age that would make me any different than a younger, like a child, say if his father was 35?
Well, so, that's an interesting thing. So men are different in the sense that, you can still, produce sperm later into your years, whereas, women have menopause and there's a hard stop. But I'm not an expert in this, but it is my understanding that there are some things that are more likely to occur with older paternal age. And it's not something I know a lot of the details about.
I heard you talk on the Huberman podcast about having traits which we often think are genetic, but that are actually attributed to early life experiences. Can you talk a little bit more about that?
There's a really interesting one of these that was discovered in World War II. So early in World War II, the Japanese army was just rolling through Asia, right? They rolled through China and British Malaysia and Singapore and Burma and they were up to the edge of India and just nobody could stop them. They were just a machine, but not everything was perfect. And part of the problem was that a lot of the Japanese soldiers were having heat stroke. It was hot there in the tropics where they were fighting, and they were just keeling over with heat stroke. And so the doctors in the Japanese armies were looking into this because it was getting to be a problem. They said, oh, well, the soldiers that are having the problem with heat stroke are more likely to come from northern Japan. You know, Japan is oriented north to south. The most northern island, Hokkaido, is pretty chilly. They've got mountains and snow. The most southern island, Kyushu, is pretty tropical. And so there's a big variation. It's like San Diego to, Seattle or something like that,
yeah.
right? And so they say, well, the people who come from the north, they're the ones who are having the problem, the hot weather. And you might think, oh, well, I know how that happened. They come from families that have been there a long time, and then gradually they've evolved to be less good in hot weather because their sweat glands aren't as good. And what it is that we actually all have pretty much the same density of sweat glands, but if you come from a hot climate, more of your sweat glands receive nerves from your brain and can get the signal to sweat more when you're hot, right? And it turns out if you come from South Japan, you've got a lot of those sweat glands that get messages from your brain. And if you come from North Japan, you got fewer of them. People say, oh, that's just evolution over a long period of time. But when they looked into the data a little more carefully, it was really interesting. It turns out that if you grew up in southern Japan, even if your parents and your grandparents and all your line before you came from northern Japan, you had lots of innervated sweat glands and you did fine in the heat. Or if it went the other way, and let's say you're from an old South Japan family, but your parents moved to North Japan and you grew up there in the first years of your life, no, you developed the sweat glands of a northerner and you'd have a problem with the heat. So it's something that you would think, oh, that's a genetic thing. Like, that got selected for by evolution over many generations. But actually, it's a developmental thing. It is something that is imprinted upon you in the first years of life and then stays with you through your whole life.
What are some things that parents could best do to set their children up for neurobiological success? Does that make any sense?
Yeah, the best thing you can do to set your children up for neurobiological success is to pay attention to them, to give them your own attention, to read with them, to play with them, to have game night, to go hiking, to do sports together, to do the normal stuff. There is no replacement for parental attention. It is the absolute number one best thing you can do for your kids. Now, I'm assuming that you're not in a situation where you're starving and, they're basically okay. They have food,
right,
they have
basic needs
medicine, they got shelter, right?
Yeah.
If you're in that situation and you're asking what you can do for your kids, it's like, it's your attention. You can't buy them fancy software and then put your own nose in your phone and not pay attention to them. The biggest thing is the habit of reading. Right? And the kids model your own behavior. If you read books, they're going to read books.
Oh, yeah.
If you're curious, they're going to be curious. If you play sports and exercise and engage with the world, then they will. So those are the things you can do. It's not like some special thing to feed them for lunch or some special, game to buy to put on their phone or their laptop.
Yeah.
Yeah.
Yeah, that's interesting. What's something that you think you inherited from, learned inherited? Is that possible to have? A learned trait maybe that you got from one of your parents early that you never thought you would have gotten? Is there anything like that kind of showed up for you?
Well, I would say the things I got from my parents are pretty, there's a lot of things my parents did that benefited me a lot. And I think the main thing is that they gave me a lot of attention. I had a really weird family.
Yeah?
Really weird family. Maybe even weirder than yours,
Yeah.
right? Okay. So my parents met when they were young, and they got divorced within a year. And then they met in Chicago. My mom moved to New York. My dad moved to L.A. After a couple of years, my dad said, let's try again. He must have been really convincing because my mom moved to L.A. They got married a second time. They got divorced a second time. But they were so hot for each other, they couldn't keep their hands off each other. And I was conceived in a hot pillow joint on Sepulveda Boulevard in L.A.
Yeah.
Right, yeah. We would drive by, and my mom would say, that's the place. Like, oh, jeez, thanks, Mom. That's embarrassing. Yeah.
Here's your spot, room 212.
Exactly. There was a magic fingers attachment on the bed, as I remember, she would say. And so, you know, I grew up a child of divorce, but my parents never divorced they were already divorced.
That's hilarious.
So there was no divorce trauma.
Yeah.
Right? That's just the way things always were. And my dad was around. I lived with my mom, but I saw my dad every weekend and every Wednesday night from dinner from where I could remember till like the day I went away to go to college. And so it was a weird way to grow up, but it was a great way to grow up because I had great parents and they gave me a lot of attention. But an example of something, my dad was a psychiatrist, an old-fashioned talking cure psychoanalyst. Lie on the couch, tell me about your dreams, tell me what you're thinking, kind of shrink, right? Mm-hmm. And so, you know, Wednesday night dinner with my dad, what would we do? We'd talk about his patients. Now, of course, like he wouldn't say their names or he'd keep it anonymous. Yeah. He was ethical.
Yeah, he was
but,
a hero.
I would say, hey, Dad, like what's up with your narcissist? You know, he had this dream. I think it's really important so, you know, it was really fun. And as I was growing up, it became clear to me, I didn't have the personality to be a psychiatrist. I'm not empathetic enough for that, and I don't have the tolerance to listen to people's problems enough for that. I'm glad there are people who do. You know,
there's
good therapists are a wonderful thing. I'm not cut out for that. My dad was really good, but I thought, you know, I want to understand the biology of this, and that's why, really, fundamentally, that I became a brain scientist. It's because my dad was a therapist, and I wanted to get at it from a different angle. Yeah.
I had a question about evolution, if we can go into that a little.
Yeah, sure.
Okay. Does evolution have like a set speed?
Wow, that is a really good question. It turns out that's something that evolutionary biologists argue about. So some people think fundamentally that evolution does have a set speed and it kind of goes on and it's always really slow. But now there's more and more evidence for something that the scientists call punctuated equilibrium. And what that just means is times where there's really, really big change that occurs really, really quickly. I mean, one example I would give is reading, right? Humans have been around for 200,000 years ago, starting in Africa. Yeah. But it's only been in the last few thousand years, a blink of evolutionary time, that we've had written language, right? So when we think about things like people who struggle with dyslexia, right? Reading is not something that our brain is deeply evolved to do, right? Yeah. We've only been doing it for a few generations in evolutionary time, so it's not that problem that in some folks it screws up.
Yeah,
you know?
Yeah, it's kind of ridiculous. We're making fun of the dyslexic kid. It's like, that makes the most sense.
That's right. This is an absolutely new thing. This is the latest trend in humanity when you look in evolutionary time is reading.
Interesting.
Yeah. So yeah. Sometimes evolution is slow and steady, and sometimes it can change really quickly. One thing that changed really quickly, is a classic thing that people talk about in evolution, is when cows got domesticated and people started eating a lot of dairy. Suddenly you started to have a situation where the gene to digest the sugar lactase, which you find in milk, which is normally present in kids but turned off in adults, it tends to persist into adults. And this only happened relatively recently, about 10,000 years ago.
When we started drinking milk.
When we started drinking milk. Interestingly, it happened separately several different times in different human groups. It happened once in East Africa and once in Turkey and once in Iraq, maybe even more times than that. But this is convergent evolution, things that happened in different places to achieve the same result, but something that happened pretty quickly and pretty recently in evolutionary time.
Do you think that could have been the cause of that could have led to a lot of different medical problems that humans face? Or,
well, there are some people who think that, dairy is really problematic in terms of disease. I'm not convinced by that, honestly. I think it bears a lot more research, but in my own life, I eat dairy just fine. I love cheese. I love pizza.
I have a little bit of cheese. I'll have a little.
And I don't think there's any reason to think that it's poison for you.
Yeah. It doesn't feel like it.
Yeah.
Like, even if I even just think about it a little, it's like, if somebody said that, I'd be like, I don't know, dude.
Here's the thing right now. Here's my theory about foods and sort of the mania for people including or not including certain foods right now. People are feeling so messed with right now. People feel so disempowered. They feel like they're messed with by the government. They feel like they're messed with by corporations, they're messed with like their boss, like they have so little in their lives they can control. But what can I control? I can still damn control what I eat.
Yeah.
Right? So people focus on that because they're feeling so fucked around with in so many other ways.
Yeah,
I understand that. And so it's like, I'm going to eat this. No, I'm not going to eat this.
Yeah.
And, it gives...
It's like, let me do something.
Right, and it gives rise to a whole lot of nuttiness. Like, oh man, I'm only going to eat meat and nothing else. Well, that's really not a very good idea. Oh, no, I got to absolutely avoid dairy because it's going to kill me. No, it won't kill you. It's okay.
Yeah.
But I understand where it's coming from. It's like, there aren't that many things left where you really feel like you control it.
Yeah. Do you think that humans can we stop evolution from happening?
No. Evolution that train's going to roll on no matter what we do. It's just, some people like to think, evolution is something that happened a long time ago and now like that doesn't happen anymore. They think technology insulates it from us. Like we don't have to worry about being cold right now because like I got a heater in my house. I got AC. I don't, my food comes to me, from DoorDash. And so I don't have to like hunt the bear to eat. And those things are true, but evolution never stopped happening. Maybe right now, the thing that we're evolutionarily selecting for is being able to deal with certain pollutants in our atmosphere, right?
Oh, right. We don't know what evolution is doing right now with us.
That's right. Evolution never stops. It doesn't stop for humans. It doesn't stop for any other.
We're all of its mice.
We're all guinea pigs in this plan. But the forces that are molding us right now are different. The planet's warming. That's molding us. We are subject to different environmental pollutants. That's molding us. Maybe right now it's going to turn out that we're being selected for people who can tolerate microplastics in their body.
Yeah.
Right? Because that is something in our environment that didn't used to be there. That wasn't an evolutionary pressure that mattered 100 years ago, but it matters right now. So evolution's still happening. Yeah,
it's constantly like the experiment is ongoing.
It is.
Oh, that's pretty fascinating when you think about it like that. When you mentioned microplastics, that's like a fear right now. Like I've honestly started to buy like cotton underpants and stuff like that because I'm just like, you start to wonder, well, how are things getting into our system, right? Do you have a lot of fear? Is that like a fear in the scientific community?
Well, I don't think you have to worry about your underpants. I mean, unless you're eating them for lunch, I think you're fine. I think you got to worry about things you're ingesting or inhaling, things that have an obvious way of getting in.
Yeah.
Right? So, worry about microplastics in your water, in your food, that you inhale, that are in your cookware that might get, those are valid things to be concerned about. If there's a plastic band in your underpants, there probably isn't really a way that plastic's getting in your body.
Got it.
Yeah.
We've been evolving as humans, right?
Absolutely.
If we develop too much technology, are we still humans at a certain point, or do we have to like reclassify ourselves or something? Does that make any sense?
Well, maybe where you're going at is like if we all have Elon's brain implant.
Yeah.
right? So Elon's got this company and other people have these companies where they're trying to, build something that would actually be implanted in your brain. And, maybe you could have a device that would enhance your perception or your cognition, like you could see in the infrared. You could remember everything that's on the internet, things of, this kind of science fiction stuff that you could imagine in the future. And if that were to come to pass, well, then I think, fundamentally you would have to think, are we still Homo sapiens or are we, Homo sapiens muscensis? I don't know.
Oh, yeah, muscensis. I see. Like that's the evolution of it, right? Because they would probably name the evolution after whoever owned it,
Well, and then, I'm deeply skeptical of everything corporate, right?
Yeah.
I get an implant in my brain. What am I going to get? I'm going to get ads.
Yeah. Yeah.
Well, you ever read the science fiction writer named Philip K. Dick? He was the guy who wrote the stories that were the basis for films like Blade Runner and, a lot of our other famous science fiction films. He was a writer who was active in the 60s and the 70s. Man in the High Castle, for example. Do Androids Dream of Electric Sheep became Blade Runner.
So he'd be a cool person to talk to.
Minority Report, right? That became that film came from Philip K. Dick.
Wow.
Right? Lots of famous science fiction stories came from his books, things that got made into shows or films. And he had in Blade Runner, you're walking down the street and things are being beamed into your retina.
Yeah.
The government wants you to go off-world and see another planet, or they want you to buy this thing, or, this company wants you to do that. And so, people have been imagining this for a long time. The science fiction writers are always ahead of the curve.
Yeah.
I remember when I was a kid, and I was a really nerdy kid, and I read a lot of science fiction. There were stories about this thing that hadn't happened yet. It was called a computer virus. And everyone's going, oh, could that ever really happen? Well, could that be a thing? Yeah, some code that could hop from computer to computer and infect it and mess with it and make it do things. And people were like, oh, could this ever really happen? Oh, maybe that's just science fiction. And then, it happened big time, right?
Yeah.
And that's our world right now. So, this is one of the many examples where science fiction writers were ahead of the curve in imagining the future.
Yeah. I mean, we're living in our own future. That's the crazy part sometimes, Like the thing we imagined when we were kids, like we're living in it, Sometimes it happens so gradually, you just don't even notice little parts of it.
Yeah, and it's not all bleak. Let me put it that way, right? It's not all bleak, right? And being a biomedical researcher, I think about this a lot. Cancer is the area where perhaps it's been the most dramatic, right? There's a kind of leukemia called ALL, acute lymphoblastic leukemia. It used to be if your kid had acute lymphoblastic leukemia, 95% they were going to die. Forget it, no hope. Now it's the other way around. 95% of kids with ALL are going to live and thrive. And this is happening more and more. We're at the precipice of fundamental new cures. So there's a very bad kind of cancer called multiple myeloma. It's a blood cancer, but it causes your bones to get brittle. Not only is the prognosis really bad, but it's a really, really bad, painful way to die. There are indications right now that there's an engineered T-cell therapy, where they take cells from your blood, take them out of your body, genetically modify them and put them back in. People are thinking it might even be a cure for multiple myeloma.
Wow.
It's amazing. I mean, right now it costs $1 million and only a few people can get it. But, there's going to be a point where that's the standard of care for people all around the world. So, let's not all be doom and gloom entirely about technological change.
It's a great point.
A lot of it is going to be really good, but it depends upon biomedical research.
Yeah, I was just about to ask you about that. Yeah, I know we had mentioned before we even started talking that the government is cutting or potentially cutting funding for biomedical research. What does that look like realistically? And then how could that affect our everyday lives?
Yeah, well, it turns out that it is a potential absolute disaster for biomedical research. So in the president's budget for the next year, 40% cut to the National Institutes of Health, about the same to the National Science Foundation. This would devastate biomedical research. It would basically, turn off the tap. So many promising things would be lost. There is so much right now that's changing in terms of new therapies for cancer, for neurological illness, new devices, new therapies. Just think about things that you know about in your own life, like these weight control and diabetes drugs, these GLP-1s, right? They've only been around for a couple of years, right?
And those are, you're talking about like Ozempic and Westwego or whatever?
Oh, yes, Wegovy, Ozempic, Zepbound, these drugs, like they are saving lives, right? It's not just like, oh, I want to look better, right? It's helping people with diabetes, it's helping liver disease, heart disease. It's remarkable how useful they are. And you might say, well, all right, but didn't this just come about from drug companies? Didn't drug companies do that? Well, no, the basic research that gave the drug companies the idea, it came from funding from the federal government. The federal government does the basic research. And sometimes, like, these are the sort of things that people like to make fun of and they think our money's being wasted. So you ever heard of a lizard called a Gila monster?
Yeah.
Right? So they're out in the desert in Arizona and places like that, and they've got venom. And in their venom, there's something that looks like this hormone called GLP-1. GLP-1 is the hormone that's secreted by your small intestine that goes to your brain and suppresses your appetite, and that's the basis. That's what these drugs like Ozempic mimic. They're like GLP-1 with some natural GLP-1 with some modifications. Now, the problem, you might say, well, people knew about GLP-1. Why can't you just take GLP-1 and inject it into your body? And the reason is it's broken down in your bloodstream like in a minute or two. It doesn't linger long enough. It turns out that there are modifications in the Gila monster venom GLP-1-like molecule that make it linger and last. And that was the innovation that allowed these drug companies to make these long-lasting compounds that allow you to suppress appetite and lose weight. And they also seem to have anti-inflammatory properties. So the receptors for the GLP-1, what it binds to make it work, is not just in your brain to suppress your appetite. Those receptors are in your heart, they're in your liver, they're in your kidneys, they're in all kinds of organs, they're in your guts, and they seem to have additional beneficial properties beyond just losing weight. But this kind of innovation would never happen if it weren't for the United States government funding fundamental biomedical research, the kind of thing that somebody in the Senate might get up and say, these eggheads are wasting our money on studying Gila monster venom. What a waste of your taxpayer dollars. This is such bullshit. But really, where did it get us? It got us to a fundamental medical breakthrough that helps everybody.
Yeah, what are some of the other positive effects of that? That's a great point, man, because you would just hear, they were studying like drool from a baby walrus or whatever, but where did it get us, right? Yeah. So bring up, what are the other positive effects of GLP-1? I never really looked at this. I hear about it all the time.
Well, so like one interesting claim that's being made right now is that these drugs to help suppress appetite also help other compulsive behaviors, whether it's drug addiction, compulsive shopping, gambling.
The GLP-1 receptor agonists, like semaglutide, show promise in reducing alcohol and opioid use disorders by targeting reward pathways in the brain and reducing cravings. They may also help by calming the stress response and reducing drug-seeking behaviors. However, more research is needed to fully understand their effectiveness and safety in addiction treatment. Are there side effects of GLP-1?
Yeah, there are. Sometimes people get constipated on them. Sometimes people feel nauseated, and sometimes
I'll get constipated off a bad waffle. So no, look, dude, I'm willing to risk.
And some people feel tired them. So there are some side effects, and sometimes they can be serious enough that people will want to quit the drug because they can't handle the side effects. But mostly the side effects are not bad.
Doesn't look like
it. There are even some hints. It's early days. I wouldn't bet my money on this, but there's some hints that it may actually be beneficial in terms of likelihood of developing Alzheimer's disease.
Wow.
Yeah. And there are some potential benefits for Parkinson's disease as well. So,
do you go on?
Right now, every drug company in the world is making another drug for this. There's an absolute gold rush for them. So right now, Lilly's got one drug. Novo Nordisk drug company has got another drug.
They're all
but there are many,
off with
many, many of them in the pipeline and clinical trials.
Wow.
And so, these we'll know more about their positive effects on things like kidney and liver disease, but we'll also know more about their effects on behavior, on compulsive behaviors like shopping, gambling, drug addiction. Which anything we can do to help people get clean, is a godsend.
Oh, for sure, man. Yeah, look, I've been down that road myself. I do want to look at what are Trump's proposed budget cuts on that?
40%.
Documents released late last week are providing new details about the breadth and depth of the spending cuts the White House is asking Congress to make to public health and biomedical research programs in the 2020 fiscal year that begins on October 1st. Among other things, the plans call for deeper spending and staff cuts at the Centers for Disease Control and Prevention, CDC, and were outlined in a less detailed skinny budget. And then scroll down to the other places you noticed. Okay, the request largely confirms cuts outlined in documents that leaked last month. It proposes to cut NIH's discretionary budget by about 40% or $18 billion to $27.5 billion and consolidate NIH's 27 institutes and centers into just 8. The reorganization would preserve National Institute of Allergy and Infectious Diseases, a couple of other places, but eliminate institutes studying minority health, alternative medicine, nursing, and global health. The remaining institutes would be folded into 4 new ones. Biomedical research proponents sharply criticize the proposed cuts. If the proposal is enacted, Americans today and tomorrow will be sicker, poorer, and die younger. Why do they want to do this, I wonder?
Well, some of it has to do with, they want to save money. I don't think this is a place to save money. Something that has to do with an actual hatred for academic scientists and people in the public health world. I think it's become a partisan issue in a way it shouldn't be, right? Everybody gets sick and everybody benefits from new therapies. For years and years and years, it didn't matter what side of the aisle you were on. Republicans supported biomedical research, Democrats supported biomedical research. It was something that people agree on. Mm-hmm. Now, just in these last in this last time, it's starting to really since COVID, it started to get really politicized. And, the Trump administration will tell you, oh, this is waste, fraud, and abuse, or this all has to do with like DEI efforts, and that's the only stuff we're cutting. But it's nonsense. 40%, it's a fucking hatchet, right? It's not just, we got rid of a few bad studies that were misguided or some waste or fraud that we found over here. It's like we are going to cut it down to the bone. And when that happens, the therapies to help everyone's families for cancer, for heart disease, for mental health, for everything that you're hoping for, new therapies and cures, all that stuff's coming to a screeching halt. And the United States has been the world leader on this. This is a place where America absolutely kicks ass. We are the acknowledged world leader in biomedical research. Wow. And to give it up would be the stupidest fucking thing we could possibly do.
How much of the funding is negatively influenced by big pharmacy stuff? I'm just wondering, is that because otherwise I don't understand. This doesn't make that much sense.
Just to be clear, this funding doesn't go to drug companies. Okay. Right? This funding goes to research institutes, it goes to universities, and it goes to the NIH itself and Bethesda Maryland, where some of the research is done. This funding, by and large, this isn't a way that the government is subsidizing Pfizer or Lilly or any of these giant corporations. These corporations are really good at taking an idea and turning it into a product, right? Okay, they're not good at the basic research that gives you the idea to do it.
Got it.
In the first place.
Is there anything in there that tells Pentagon? That's defense stuff. That's horrible. Department of Homeland Security. I feel like all these people are building us up to be in some type of a war. I don't even know. It's very scary days. Oh, the budget proposal aims to cut funding for research related to radical gender ideology and diverse racialism. That sounds so vague, though.
Well, the truth is that, so there have been some grants that do involve stuff like that, but it's a tiny, 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 tiny fraction, right?
Yeah.
Don't believe that 40% of the NIH has to do with studying things like trans folks. I mean, I think it's perfectly legitimate to study trans folks myself.
Oh yeah, I'm curious about them. Most people are curious.
Even if you think that's bad, that's like a tiny, tiny fraction of the NIH. There's not 40% of that to be cut.
I wish we could talk to someone who was involved with I don't know if it's Doge or what the exact group is that's organizing a lot of these proposed cuts.
Well, you've had RFK Jr. on here.
Yeah.
Yeah. So, he's...
Maybe if we get to have him back on and we get to talk to him about it.
He's the one who's involved in this and the new head of the NIH and the new head of the CDC. These are all folks that are fundamental to this.
Yeah. What did that article say about RFK? I saw the one part. Let me see. The budget request reflects priorities advanced by the Department of Health and Human Services Secretary Robert F. Kennedy Jr., including a focus on food additives and chronic diseases at the expense of infectious disease studies and a real-world data platform to allow scientists to study the causes of autism. Oh, that's awesome. It also proposes using artificial intelligence and big data analysis to research the exposome, the collection of environmental factors that can influence human health. So I wonder if they're just trying to redirect it to things that he cares more about.
Well, so I think the thing to realize is, first of all, it's a 40% cut. So it's not like you're taking the same pot of money and then just reshuffling around to different priorities. First of all, you start with a 40% cut. And then the 60% that's left, you're going to take away from stuff like vaccines and put it into bullshit cold plunge therapy and other stuff that are his pet projects.
Yeah.
But I'm curious. Let me just be clear. Okay, there's some things where I really agree with RFK Jr. He is absolutely right that we should be taking a closer look at food additives. He is absolutely right that ultra-processed foods are a big problem in health, and he is absolutely right that environmental pollutants are a big problem in health, and there should be a lot more attention paid to that. Where I get off the bus has to do with cutting all these other areas that are so very, very promising.
Yeah.
And also with some of the other very unproven things that he has advocated for. So, for example, the drug ivermectin, he's a big fan of it for COVID and other things. It's nonsense. It doesn't work. It's not true. It's fraudulent. Don't believe it.
I've had friends that have taken it, have had success with it.
Yeah, well, that's the reason we don't make biomedical policy based on anecdotes that something that happened to our buddy, right?
Yeah.
We do studies for it, right? And so, like I go and I take some vitamin C and I feel better from my cold. Well, maybe I was going to get better anyway. We don't know.
Yeah.
Right? Maybe the vitamin C did something. Well, what's the way to know that? You have to do a real controlled study the proper way.
Assuming that that there aren't budget cuts, or even assuming that there are, right? What do you feel like the next 10 years of biomedical research looks like?
Well, I think it's going to involve there are a lot of really exciting things that we're on the precipice of. One of them is really finally realizing the promise of individualized medicine. In other words, you go in, you give a little blood, or they scrape the cells from your cheek. They read a lot of your genetic situation, and they know how to give therapies that are precisely designed for you for the very best outcome and the fewest side effects. This is the sort of thing that's already happening in cancer, right? Like it used to be like you went and you'd say, oh, you got lung cancer. All right, well, we're going to treat you generically for lung cancer with the thing that works the best for the most amount of people. But it turns out that like depending on the flavor of what's in your tumor, actually for some people, it might be much better to get this one, and some people it might be better to get that one, right? And this is something where AI is actually and machine learning are extremely valuable. Another thing that's extraordinarily exciting is the use of gene editing technology, so-called CRISPR. You may have heard that term. CRISPR is a technology for changing your DNA. So what this is, like if you have kids that are born with these rare genetic diseases where like there's a disease where you can't do your metabolism right and you build up ammonia in your body, and these kids die within a few years, right? So right now there is great promise for using CRISPR to be able to modify their DNA to correct the genetic deficit and allow them to live normally. This is just starting right now. It's, the very dawn of the age of CRISPR therapy, but the next 10, 20 years are going to see this sort of thing explode.
Is AI helping us?
AI is helping us massively because there are certain sort of things where what you want to know is like what happens when you put 1,000 different variables that you measure from your blood test, from testing your DNA, in to predict what the best therapy is for you or how you are likely to respond to a different drug or antibody or something like that.
Right.
And AI is extraordinarily good. There is a fellow named Eric Topol at the Scripps Institute just wrote a book called Super Agers that is really excellent. And he spends a long time talking about the promise of AI and big data in the next era of medicine. He'd be a wonderful person for you to have on the podcast.
Thank you, David.
Theo.
Yeah, I'm going to check that out. Super Agers.
Yeah.
Do you think? I wonder if one of the reasons why they could be, or one of the reasons why they're even could be proposing budget cuts if they think that AI would it save money, you think, for research?
No, AI is in other words, bringing AI to medicine is a good idea. I mean, it's not always a good idea, but there are many areas where it is genuine. It's not like doing things with AI is going to allow you to achieve economies of scale or, cut this or do things in fundamentally different ways so much as it's another tool in the armamentarium. There's nothing wrong with bringing AI to biomedical research.
Right.
What's wrong is that 40% cut. And it's not just that. They're doing dirty tricks, right? Congress allocates money for biomedical research, and then right now the administration is just slow-walking actually allocating it. So the rate at which the money is actually getting to the scientists to support the research is only about half the level that it was the previous year. And this is illegal and unconstitutional. The Constitution says the power of the purse resides with Congress.
Yeah.
And, the executive branch is saying, well, no, we're not really doing anything. But, if you want to throw sand in the gears, if you want to slow things down and screw things up, there's a million ways to do it.
Oh, yeah. Well, it's the same thing happened. We had like a Border Patrol guy on, and he said that they would arrest the same guys over and over again, and the the judicial branch, they would never process any of them. So it was like these parties just keep kind of finding ways. There's always a way for them to choose to make things tougher on the regular person, I feel like, Well, yeah, there are ways to get around, to claim you're not suing something but really do it. Claim you're not cutting biomedical research. Point at the next guy.
But actually just will slow down getting the money out there, and fundamentally you're cutting biomedical research. Or in this case, the Trump administration is actually saying, yeah, we want to cut 40%, and that's a good idea. And then what it's really going to be is more than 40% because it's going to be 60%, and then they're going to throw the sand in the gears of the 60, and it'll be even less than that.
Yeah.
Yeah.
I'd love to get to talk with with Bobby Kennedy again to learn more about that,
Yeah.
So hopefully I'll get that opportunity. And if I do, I'll make sure to bring that up.
Please do.
Yeah, I appreciate that. Yeah, I think one thing that makes us America also is that we are always trying to be at the forefront, that we are trying to research, trying to figure out the best way, right? And trying to figure out new ways, right? I think that's one thing that's always made us America. Your cancer diagnosis. Can I get an update on it? Is that okay to ask?
Yeah, that's totally okay to ask. Thanks for asking, actually. 4 years ago, I had a giant tumor removed from my heart. It's a kind of cancer called synovial sarcoma. The tumor was about the size of a Coke can.
Ooh.
I know. It was a crazy, awful surgery. And the tumor had grown into the wall of my heart. So in the end, they couldn't take it all away. They could take away most of it, but the part that was in the wall of my heart, if they took that, I'd have a hole and my heart would be broken and I would died right there on the table. So I got out of that. They biopsied it. They said, yeah, it's this malignancy. And the oncologist said, you got 6 to 18 months to live. Well, that was over 4 years ago. And so I'm feeling very fortunate to still be here. I didn't expect to still be here. The amazing thing is during all this time, the only thing that's made me feel bad has been the therapy. In other words, recovering from the surgery made me feel bad. The chemo, the radiation made me feel bad. But I've never actually had any symptoms from the tumor itself. I got so now the tumor is like the size of a walnut and it's in the wall of my heart. And it means my heart muscle can't work quite as well, as efficiently. So I can't do really high intensity exercise. Like I can't really run full out anymore. I used to like to downhill ski. I don't downhill ski anymore.
Bummer.
But, pretty much everything else that I want to do, I can do. I can be completely active in my world. And so one of the things is that it's made me really interested in cancer. Honestly, before I thought cancer was a kind of a boring area of biology. Oh, cells start to grow and they keep growing. It's important for people's lives, but, intellectually I don't really care about it. Now, of course, I'm really interested in it. And one of the things that is most interesting to me is that it's come full circle. So I'm a brain researcher. I got cancer. It turns out what we're learning now is that most solid tumors in the body eventually become innervated. In other words, nerves come from the brain and the spinal cord and they come to the tumor and they wrap around and they send messages. And when tumors get innervated, it's almost always bad news. When a tumor gets innervated, it means your prognosis is worse, the chance of it spreading is more, the chance of the tumor growing is more.
And the innervation happens so that the user will know they have the tumor? So the person...
No, you're not. This is all subconscious. In other words, you don't feel it. It's like, I can't go, oh yeah, I feel the tumor in my heart right now.
Right.
I can't do that.
But why does the brain do that?
Well, we don't know. But it happens. But here's the interesting thing, right? So people ask me, why are you still alive after 4 years? To what do you attribute it? And I say, when I say this, I am not being like woo-woo or metaphorical. I'm saying I attribute it to the love of my wife. I have a wonderful wife. She is the best. And I say my wife's love is keeping me alive. And that sounds like some very airy-fairy kumbaya kind of thing to say. But what's exciting to me is that there may well be a biological basis to this. When I receive my wife's love, my brain's reward circuitry, those dopamine neurons in the ventral tegmental area that we were talking about before, they light up, they fire. We now know from studies in laboratory animals that when those neurons fire, it activates the immune system in a way that can fight cancer.
Love will keep us alive.
Love will keep us alive, right? Love will not tear us apart, like Joy Division said. Love will keep us alive.
Yeah.
And I think that there are potential biological ways in which these things that we think of acting on sort of the spiritual level, love and faith and community, can affect your body and the progression of disease. I think the way that happens isn't a mystical way. Ultimately, it's a biological way, and ultimately we'll understand that. And that's what my new book is going to be about. My new book, which I'm writing right now, won't be out for quite a while, is going to be called The Real Science of Mind-Body Medicine. And it's going to be about exactly that.
Let's go, David. Man, that's so fascinating because you're talking about like a cross between, well, we're talking about, throughout this, we talked about love. We started off with talking about love.
Yeah.
And we talked about faith and science and how they don't have to be just one or the other, right?
Yes.
And then see a moment really where your wife's, your faith and your love that you have with your wife, something that's tangible, that's real, and how that makes you feel scientifically affects the way your body feels and behaves.
That's right. And, you know, we kind of know this already. So you've probably heard of the placebo effect, right? A sugar pill or a sham injection. Placebo effect, the best thing it's for is chronic pain. Placebo effect is a pretty strong effect for chronic pain. But how does the placebo effect work? Well, it turns out that if you give people Narcan, you know, this drug that you use to save people if they're having like a fentanyl or a heroin overdose, it blocks the receptors for both, you know, fentanyl and heroin, but also your body's own natural morphine-like molecules, the endorphins. This drug will block the placebo effect. So the placebo effect, you think, oh, it's a psychological thing. It acts on this different realm. It acts in the clouds somehow. No, it doesn't. It acts on the damn mu opioid receptor. It's a biological thing, right? Wow. So the idea that the thoughts you have, the beliefs you have, your emotional state can affect your brain and your body in fundamental ways to do things like change the progression of your cancer, to change your chronic pain, to influence depression and anxiety. These are, you know, these are areas that I think are some of the most fascinating
Me too.
things to research, and there's going to be an explosion of this in the next 10 years.
Let's go. Well, that's very exciting, man. I appreciate you for coming and helping us think about stuff. I appreciate you for thinking about like how we feel and some of the sciences behind it, and just for answering some of my questions, man. I couldn't be more grateful for your time. And are you going to be okay with your health? What's the latest?
Well, you know, I go in and I get a scan every 6 months. And at any point, they could say, sorry, dude, the scan, you know, your cancer's now spread to your liver or your lungs, and then things would be a lot worse. And I'd have to decide, you know, do I do another round of chemo? Do I do surgery? Do I say, fuck it, no? You know, but fortunately, that hasn't happened. I get the scan every 6 months, and so far it's been okay. But, you know, in planning your life, you know, so I closed my lab, right? Because my lab is full of people who are getting their training, you know, they're getting their Ph.D., they're getting their postdoctoral training. If I kick off in the middle of their training, they're out of luck. Like it's really bad for them. So I don't think morally that I can take somebody on new in my lab if I can't guarantee that I can see them through to the end of their training.
Yeah.
And so when I got diagnosed 4 years ago, I told the people in my lab, I said, hey guys, you know, you might want to bail out because, you know, I'll support you because, you know, I can't guarantee I'm still going to be here.
Yeah.
And, you know, they all stuck with me, man. I don't know, really, you know, they all stuck with me, and I thought, oh man, I really can't die now because like I don't want them to be screwed because they were loyal, right? So there's a lot of reasons to want to be alive, but that's one of them, is to not screw your good friends and, you know, the people you work with. And so fortunately, they all got to move through, do their projects, publish their papers, get new jobs, move on to the next stage of their life in a natural way. Last November, the last dude in my lab finished. He's done. I closed the door on the lab. So I still work at Hopkins. Now I teach more. I write more. I do a little more admin. But I'm still a Hopkins professor. And so, I'm living life to its fullest, but, you know, at any moment the hammer could drop.
Well, Let's hope the hammer stays alive and vigilant and far away from dropping, man.
Thank you.
Yeah, thank you so much for, well, thank you, man. Thank you just for research, and you start to realize how important research is too, even just talking to you, and then it's like you being a person that's dealing with this right now, you're like a living example of, hearing you say that, it's powerful because it's like we need research in order to help people that are sick, and it's just important. So I just think, and just the power that we can have to help each other, and the science behind, believing in one another, all of that. It's just really, man, I can't thank you more for your time.
It's been a pleasure to be here.
Yeah. You have your book, Unique, The New Science of Human Individuality. And you're working on a new project. Keep working on stuff, man. I'm excited to hear more and just be able to have another conversation down the line.
All right. Well, maybe you can have me back when the new book comes out. That would be fun.
Yeah, that sounds cool, man.
All right.
All right, David Linden, thank you so much.
All right. Thanks so much, Theo. It's been a pure delight to be here.
Now I'm just floating on the breeze, and I feel I'm falling like these leaves. I must be cornerstone. Oh, but when I reach that ground, I'll share this peace of mind I found. I can